Hi student, welcome to DPCIM. So now we are going to discuss about matrices for intermediate students. For inter student, the first paper called A, first year intermediate, the first paper called A and matrices. Here we are going to discuss about what is a matrix, what is a matrix, and different types. And in this video we are going to learn the addition of matrices and scalar multiple scalar multiple of a matrix and equality of matrices. So here let me explain what is a matrix. What is a matrix? See, matrix is nothing but it is an ordered rectangular array. It is a ordered it is an ordered rectangular array of of elements. See here, what is a rectangular array of the elements? See, it is a rectangular box, and these are flower brackets to represent the matrix. So these are brackets. So within the elements, so the elements are arranged in a rectangular form. That is, for example, 1, 5, 6, 2. So like this. So this is array of an element. These are inside of the 1, 5, 6, 2 are called elements. 1 comma 5 1 5 6 2 are called elements of the matrix. Now this is ordered rectangular array, so we are arranging these numbers in this form. It is called matrix. Okay, now here let me explain next the concept order of matrix. The order of matrix explains us the number of rows and columns. Suppose if you take here example of this 1562, here number of rows and columns we have to find. See, number of rows. How many number of rows are here? 1 and 2. There are two numbers are there. Two rows are there. Two rows and two columns. This side, so left side and this side. Two columns. Two columns are there. Two rows and two columns, and it is represented with 2 by 2. Here actually we are using graphs, but we have to pronounce we should pronounce it like a by 2 by 2 matrix. That means the first represent number of rows, and second one represent number of columns. So this is order of matrix. Now let us discuss types of matrices. What are the different types of matrices we have? We'll discuss here. The first one is square matrix. Square matrix. What is a square matrix? See, if number of rows and columns are equal in matrix, that matrix is called square matrix. Is called what? Square matrix. For example, see, in the previous one we learned that is two commas. For example, 3 5 1 2 minus 3 1 6 5 0. Here number of rows. Think it of number of rows. That is 1 2 3. We should write down of the matrix like this. 3 by How many columns are there? 1, 2, 3. 3 columns are there. That is 3 by 3. Here number of rows and number of columns both are equal. Then it is called a square matrix. It's called square matrix. Next, we'll go for rectangular matrix. It is quietly opposite to the square matrix if number of rows not equals to number of columns. Number of rows is not equals to number of columns. So both are different. Here both case here different. Here square matrix means number of rows and number of columns should be equal, and rectangular matrix means number of rows not equals to number of columns. For example, 5, 1, 3, 2, minus 1, 5. Now you can observe the number of rows are 2 here. The number of rows are 2 and the number of columns 1, 2, 3. Number of columns are different. So here when we compare with these two, here there is a slight difference is there. When number of rows and number of columns are equal, then it is called square matrix. If not, it is called rectangular matrix. So we'll go for one more matrix, that is diagonal matrix. Diagonal matrix. What is the diagonal matrix? Here diagonal matrix, and I'll go with along with this I'll go with square matrix. The scalar matrix, sorry. What is the difference between these two? Let me explain. Diagonal matrix. Diagonal matrix, the principal diagonal. What is a diagonal? Diagonal is nothing but, you can observe here, 1, for example 0, sorry, with this, yeah, 1, 0, 0, 0, 5, 1, 0, 0, 0, 3. Now you can observe this is called principal diagonal. We call it as principal diagonal. Why it is called a principal diagonal? That is, see here, this number, this element represent the position of this element is, this is first row and first column. This is first row and first column, and this is second row and second column, and this is third row and third column, right? So this is a difference here. So and here, this is called diagonal matrix. This is called diagonal matrix. And coming to the scalar matrix, it is also, we should have the principal diagonal as something. You can take any one number and remaining are 0. Only principal diagonal contains equal numbers. That is, if you have a 2, 2, 2, then it is called a scalar matrix. And here you can observe in the principal diagonal, the numbers are, elements are different. 1, 5, 3. No need, all should be same. Here compulsory in the scalar matrix means we should have the equal elements, that is 2, 2, 2 in a principal diagonal. That is called a square matrix. And we'll go for unit matrix. Unit matrix. Unit matrix in principal diagonal, compulsory we should have 1. Compulsory we should have 1. Then it is called unit matrix. If this is 3 by 3 unit matrix, we'll go for 1 by 2 by 2. 1 by 1 also we have, that is 1 by 1. And here you can observe, and it is also defined as, it is denoted with I 3 by 3, I 2 by 2, and I 1 by 1. This is called unit matrix, and it is denoted with I. And we'll go for another method, another definition. Sorry, that is zero or null matrix. Zero or null matrix. In a matrix, if all the elements of the matrix are 0, all the elements of the matrix are 0, then it is called zero or null matrix, and it is denoted with Z. It is denoted with Z. It is Z 3 by 3. and we'll go for 0 0 0, and it is Z 2 by 2. It is 2 by 2. Z, capital Z, this is 2 by 2. So according to your situation, we have to go for 0, 2 by 2 or 3 by 3, whatever. And next we have row matrix and column matrix. Row matrix and column matrix. Before going to this, we should concentrate on a particular that when we are talking about row, don't bother about the columns. And when you are going for the columns, don't think about row. Why? Let me explain here. See, row matrix. Row matrix means in a matrix, if we have only single one row, if we have only one row, then this row is called. See, don't bother about this number of column. Number of column is 3. That is, this order of this matrix is 1 by 3. But here number of rows, how many we have? 1 we have. Then it is called a row matrix. Then it is called a row matrix. Suppose I'll go with the same 5 6 1. Don't go for the number of rows. The number of column is only 1 we have. Then this number of column in 1 is there, no? So then it is called a column matrix. This is called column matrix. So that is the difference here. When you are going for row, don't think about a column. When you are going for column, don't think about a row. Then we have to concentrate on the columns. So if number of columns is 1, then it is called what column matrix. If number of rows is 1, then it is called a row matrix. Then we'll discuss about the triangular matrix. There are two triangular matrices. One is upper triangular matrices and lower triangular matrices. Now let me explain what is the upper triangular matrix. For example, if you have 5 6 7 0 3 2 0 0 1. Now you can observe that the principal diagonal. What is you have principal diagonal? This. If the principal diagonal, the elements which are down of this principal diagonal are become 0, and the top of this one is there, then it is called a upper triangular form. So you can observe that the elements are non-zero. Non-zero elements we have non-zero elements are there in the upper hand. So then it is called upper triangular form. And suppose I'll take the same thing here, 5 3 1. I'll take 0 here, and remaining I'll take 6 7 2. This is the principal diagonal now, and on the top we have zeros, and bottom we have non-zero elements. That means now we can write this is lower triangular matrices. So these are the concepts of a definition. In the future we can go for the more definition of the matrices. We don't have more than that. More than this. If you have any doubt, you can comment in the comment section. Then we'll go for the next addition of matrices. Addition of matrices. What are the additions? For example, find x if a is equals to 1 5 3 6 3 1 3 4 1 and b is equals to 1 minus 3 4 0 1 5 3 2 1, and such a way that x is equals to a plus b. That means after adding a and b, then you will get x. But before going to addition, we should think the number of, see, the order of the two matrices are equal or not. What is the order of this matrix? This is 3 by 3, and order of this one is 3 by 3. Obviously we can go for it. Then x is equals to, while you are going for addition and subtraction and multiplication, first of all we should check the order of the matrices. Then only we have to go for the operation. Let us go for a plus b. A means what? You have 1 5 3 6 3 1 3 4 1, and I'll go for 1 minus 3 4 0 1 5 3 2 1. While you are going for addition, sorry for this, we have to go for addition, right? While you are going for addition, first the first element, that is this element, is to be taken with along with this element, that is 1 plus 1. and second row first row second column, first row second column, we have to go for 5 minus 3 plus means only minus only. So right now 3 plus 4, I'm going a little bit fast, then 6 plus 0 and 3 plus 1 and 1 plus 5. You should compulsory should improve your eyesight eye fast, right? So 4 plus 2, then 1 plus 1, then add all those things. 1 plus 1 is 2 and 2, 3 plus 4 7, 6 4 6 6 6 2. So this is your addition of this. Now he has given that x is equals to a plus b, then my x is 2 2 7 6 4 6 6 6 2. Right, so this is addition of matrices. Now this is a concept of addition of matrices and scalar multiple. Scalar multiple, so multiple, right? Suppose a is equals to minus 5 3 2 1. Now if you want to multiply scalar multiple of the matrices, for example 5 is a scalar, then if you want to find a 5a, then we can go with 5 into minus 5 3 2 1. That means you can multiply this 5 to all the elements of this matrix. That 5 into minus 5 minus 25, 5 3 is the 15, 5 2 is the 10 and 5 1 is the 5. This is scalar multiple of a matrix. You can go for directly. Now equality of a matrix. Equality of a matrix is nothing but I'll go with an example. So for the example, suppose that x minus 3 and 2y minus 8 and z plus 2 and 6 should be equals to 5 2 minus 2 a minus 4. Now if they are saying that these two are equal, these two matrices are equal, that means nothing but the first element of the matrix is equals to the first element of the second matrix. That means x minus 3 is equals to 5, then you can find that x is equals to 8. Alright, now 2y minus 8 is equals to 2, then y value, that is 2y is equals to 10, then y value is 5. In the same way, z plus 2 is equals to minus 2, z is equals to minus 2 minus 2, then z is equals to minus 4. And you can go for 6 is equals to a minus 4, then a value will be 10. So these are the way to find all those things here. If you have any doubt, all those things, then you can comment on the comment box. Thank you. Thank you for this.